Alright, today we're going to take a look at an interview question, longest substring without repeating characters. Let's start with the problem description. It's pretty straightforward. You're given a string S, and your task is to return the length of the longest substring that contains no duplicate characters. Let me give you a quick example. Say the input is this. The longest substring without repeating characters is A, B, C, which has a length of 3. So, we return 3. Now, how can we solve this? Sure, we could brute force it. That is, we could generate all possible substrings and check which ones have no duplicate characters. Then, keep track of the longest one. But as you can imagine, that would be really inefficient. It'd take a lot of time. Not something we want in an interview scenario. So let's think about how to do this more efficiently. Since we need to explore all possible substrings in a linear fashion, we'll use 2 pointers, one called start and the other called end. Now, in order to efficiently check for duplicates as we scan through the string, we'll need some kind of data structure. The best choice here is a hash map, because it lets us check if a character exists and look up its index in constant time, O of 1. Let's call this map index map. As we iterate through the string, we'll use this map to store the index of each character we encounter. We'll start with both start and end at 0. Then we'll move end 1 character at a time to the right, expanding our window. If the character at the end of the window hasn't appeared before in the current window, we're good. We can safely include it in our substring. But what if it has appeared before? Let's say we're adding the character D, but we've already seen D somewhere earlier in our current substring. Now here's the key part. Do we need to go back and check every possible start value from where we are to find a valid window again? Of course not. We can instantly jump the start pointer to the position right after the previous occurrence of that character. So instead of doing extra checks, we just move forward efficiently. This technique lets us skip over invalid substrings and ensures that we're always working with a valid window. It's clean and fast. I love it. Alright, let's walk through an example step by step so this really makes sense. Let's say the input string looks like this. We start with both start and end at index 0. The character at end is C. Is it in our index map? Nope, it's not. So we don't need to move start. Our current substring is C, and we update max length to 1. We also store C in the map with its index. Now we move end 1 step to the right. Now it's pointing to A. Since A isn't in the map yet, we're good. Our substring is now CA, and we update max length to 2. Next, end moves to B. Same deal. B is new, so our substring becomes CAB. We bump max length up to 3. Then end moves to D. No duplication yet, so we include it as well. Substring is CABD, and max length becomes 4. Now end moves again, and we're back at A. But wait, A is already in our hash map. That means we've got a duplicate. We don't need to do anything fancy. We simply move start to the index right after the previous A. That gets rid of the duplication. So now our substring is BDA, which has length 3, so max length stays at 4. Don't forget to update A in the hash map to reflect its new index. We continue. End moves again, now pointing to D. That's also already in our hash map, and it falls within our current window. So again, we move start to 1 index after the last D, effectively cutting off the duplicate. Then we update D in the hash map with its new index. Next up is C. Now, here's something interesting. C is in the hash map, yes, but it's not in our current substring window anymore. That means we don't treat it as a duplicate. We can safely include it in our substring. So our final substring is ADC. Its length is 3, which doesn't beat our current max length of 4. And we're done. Alright, now let's take a look at the code. I think things will make even more sense once we see it in action. First, we'll define a dictionary to keep track of each character's last seen position. Then, we'll set up a couple of variables, one to track the start of the current substring window, and one to keep track of the maximum length we've found so far. We don't need to define end just yet. That'll come as part of the loop in a second. Now, we loop through the string. End will go from 0 to the end of the string, one character at a time. Now here's where the fun part begins. We start looping through the string. At each step, we check the current character and ask, have I seen this character before? And if I have, was it seen somewhere after my current starting point? If the answer is yes, that means we've hit a duplicate that's still part of our current substring. So what do? We move our start position, we jump it forward right past where that duplicate character was last seen. That way, we're always working with a clean substring that has no duplicates. If we haven't seen the character before, then we just keep going. No need to change the starting point. After that, we check how long the current substring is, from start to the current character. And if it's longer than anything we've seen before, we update max length. Then, finally, we update our dictionary to say, hey, we just saw this character at this new position. And that's it. We keep moving through the string one character at a time, repeating this process until we reach the end. Once we're done, max length will hold the answer, the length of the longest substring without any repeating characters. Now, let's run the code together. Just like that, it works. Nice job sticking with it, and I'll catch you in the next one.